Welcome to Alphanumerictricks. Today we are going to see problems under Lagrange's linear equations. We have already 3 problems and previous videos. If you want, please have a look on it. Now we are going to see a very important problems in this video. The first one is solve mz minus ny into p plus nx minus lz into q is equal to ly minus mx. And next problem is y minus xz into p plus yz minus x into q plus x plus y into x minus y. Now we will see how to solve these two problems. Solve mz minus ny into p plus nx minus lz into q is equal to ly minus mx. We have to find out the solution for this. This is of the form Pp plus Qq is equal to R, isn't it? Capital P is there, small p multiplied by small p, and some functions in terms of x and y, that is multiplied by q, and some functions in x, y and z. So we have, this is called a Lagrange's linear equation. So this is our given problem, and this is of the form Pp plus Qq is equal to R. Now we have to write, this is our P and this is Q and this is R. We have to mention it. Okay. So P is equal to mz minus ny, Q is equal to nx minus lz, R is equal to ly minus mx. Next we have to write the subsidiary equation or auxiliary equations. That is of the form dx by p is equal to dy by q is equal to dz by r. Okay. After that, you have to substitute the values of P, Q and R. That is given in our problem. We already written this. So, we have to substitute. Dx by P value is mz minus ny is equal to dy by Q value is nx minus lz is equal to dz by R is ly minus mx. Now, this is our first ratio, second and third ratios. We have to number it. After that, here when you are grouping these two terms, none of the terms in first two, none of the terms get cancelled, isn't it? Here mz, here there is no mz here, and ny there is no ny here. So none of the terms is not possible, and that is not get cancelled. Sorry. So here also in second and third ratio also none of the terms get cancelled, and 1 and third also comparing this, none of the terms get cancelled. So only possibility is we have to use the multipliers to get a two independent solutions. That is, for two solutions we have to go for multipliers. Now we will see how to use the multipliers. When you are using the multipliers, we have to, that each ratio will be equal to 0. That is, when you are after using multipliers, you have to add all the terms. That is, you have to add numerator separately and denominator separately. And after adding this, the denominator should be 0. Then your integration becomes easy. We can find out the solution. So here, when you are adding directly mz minus ny and nx minus lz, and next term is ly minus mx. Here there is no mz term, but here we have to multiply this by using the multipliers. If it is here you have z, then this is z and this having x. Here you have x and this with z. You can get cancelled. Mx and Mx get cancelled. X and y. Here nx is there. So here you have to multiply this by y. So you have x, 1y get cancelled. And here nxy, here nxy get cancelled. And lyz, here lyz get cancelled. So first we use the multipliers x, y and z. Okay. So using the multiplier, this is the way you have to identify the multipliers. Okay. So using multipliers x, y and z, you have each ratio. This word is very, very important. So without using anything, you don't write each ratio. That is, we are equating this ratio to some our new term ratio. Okay. So each ratio is equal to, that is when the meaning of multipliers is you have to multiply first ratio by x, numerator and denominator. Okay. Second ratio by y, numerator and as well as denominator, and is the third ratio by z, and you have to add all the terms, numerator separately and denominator separately. So when you multiplying this by x, you have x dx plus, here this by y, you have y dy plus, here by z, so z dz divided by this term, you have to multiply this by x into this term plus y into this one plus z into this one. Now you have to take x, y, z inside the terms. Okay. So when you're taking x, y, z, you have x dx plus y dy plus z dz by, that is the term is you have x into mz minus ny plus y into nx minus lz plus z into ly minus mx. This is the term we have, isn't it? So we are taking x inside. X mz minus x ny plus y nx. This is your y nx minus y lz plus z ly. This z ly here we are writing, and minus z mx, that we have written this. Now here x m is z, and here x m minus x m is z, x and y. Here also you have x and y plus and minus, yl is z, yl is z. So all the terms get cancelled. So you have x dx plus y dy plus z dz by denominator 0. So each ratio is equal to 0. When you're taking this to other side, on the 0 into all the ratios becomes 0. So you have x dx plus y dy plus z dz is equal to 0. Okay. Now we have to integrate this. Okay, we can easily integrate this one to get a solution. So x dx is x squared by 2 plus y dy is integration of y dy is y squared by 2 plus z dz is z squared by 2. Now we take this to be some constant c1. Okay, and then this c2 is taken to other side because you have all the terms having 2. So x squared plus y squared plus z squared is equal to 2c1. You take that to be another constant, which is a. So x squared plus y squared plus z squared is equal to a, which is our one independent solution. Okay, and the next independent solution we have to find it out. We have to go for the multiply. See, I already in the starting of the problem I told you that you have to obtain two solutions using multipliers only. So we search for some other multipliers using multipliers. That is, first term is dx by mz, this and this, mz minus ny is equal to dy by nx minus lz is equal to dz by ly minus mx. This is our ratios, isn't it? Here we have to use the multipliers. Already use the multipliers x, y, z. Here another term here is mn, l, nl and n, lm is there. Okay, so we try with the multipliers lmn. Okay, lmn. We use the multipliers. Here l is missing. Here n is l is missing. Here n is missing. Here m is missing. So use the multipliers lmn here. Okay. So each ratio is equal to L dx. Here also you have to multiply L, and here also you have to multiply, sorry, L, M, N, and here M into this, N into this one. So we have L dx plus and added L dx plus M dy plus N dz divided by L into mz minus ny plus M into nx minus lz plus N into ly minus nx. Now you have to take lmn to inside. So L dx plus M dy plus N dz divided by L mz minus L ny plus M nx minus M lz plus N is taken inside N ly minus N is taken inside N mx. Here we have to cancel this. L mz, L minus L mz minus L ny plus N ly plus mnx minus mnx. These terms get cancelled. So the denominator becomes 0. So L dx by L dx plus M dy plus N dz by 0. Here you have each ratio. Okay, we are equating all the ratios. When you're taking 0 to the here, ratios into 0, it becomes 0. So you have L dx plus M dy plus N dz is equal to 0. So from that we have to integrating. We get the second independent solution. Okay, so integral here. integral L, M, N are constant, isn't it? L into integral dx is Lx plus M into dy is integral dy is y plus N into integral dz is z plus a constant. This is our next solution. So general solution of the given problem is phi of u comma v is equal to 0. We have to combine u and v terms. What is u? U is phi of x squared plus y squared plus z squared, and v is Lx plus my plus nz is equal to 0. This is our required general solution for the given problem. Okay, now we pass on to the next problem. Solve y minus xz into p plus yz minus x into q is equal to x plus y into x minus y. Okay, so here also P into P is there, and that is capital P, the small p, and Q is there, and R term is P, Q, R term is there. So this is the of the form Pp plus Qq is equal to R. Okay, now we have to write the values of P, Q and R. P is equal to y minus xz, Q is equal to yz minus x, and R is equal to x plus y into x minus y. This is sometimes this is of the form x square minus y square, x plus y into x minus y. Sometimes in your problem, instead of this way also given x square minus y square, and you have to take it to be x plus y into x minus y. For simplification, whichever you need, you can take it. Okay, now we have to write the auxiliary equation or subsidiary equation. Dx by p is equal to dy by q is equal to dz by R. Now we have to substitute the values of P, Q and R. So dx by y minus xz is equal to dy by yz minus x is equal to dz by, this term can be written as x square minus y square. Here also grouping is not possible. None of the terms get cancelled when you grouping. Only possibility is, that is, you have to go for multipliers. We will check. Okay, using the multipliers. Here first you have to use the multipliers. This term is there, x squared minus y squared is there, and here in this term y is there, y is there, and here x is z, y is z minus x, x squared, y squared, all the terms are there. So suppose we multiply this way, y dx, x dy. What happened? Y squared minus y x z and y x, here we have to take this term by x, because x squared y squared is there, but here you have x squared y squared is not there. So when you adding, the terms get cancelled. That's why we change it to another way. Okay, and then here we multiply this by x. So what happened? X y z minus x squared, and here x squared is there, y squared is there, and here x y z minus x y. When you adding these two terms, this is get cancelled. What about the another multiplier? You just want this x squared minus y squared as it is. So we add the multiplier 1. Okay, we add the multiplier 1, and then these terms get cancelled. You get the answer to be 0. So we have to use the multipliers y, x and 1. We use the multipliers y, x and 1. Okay. So each ratio will be equal to y dx plus x dy plus, here 1 is multiplied, so dz divided by y into y minus xz plus x into yz minus x plus x squared minus y squared. Okay, so we have to take the terms inside, y dx plus x dy plus dz divided by, we have to take this y squared minus xyz plus xyz minus x squared plus x squared minus y squared. And here this y squared get cancelled. Minus xyz plus xyz get cancelled. Minus x squared plus x squared get cancelled. So denominator you get the value to be 0. And one thing you should remember, don't multiply the, don't memorize the multipliers. Depending upon the problem, you have to choose it. That is, you have to trial and error method, you have to choose your multipliers. Okay, by practice you can do it very quick manner. So practice is very, very important. So you have to do more problems. That is very, very important. Then only you can easily identify the multipliers. Now, this 0 goes to this side, it becomes 0. So, you have y dx plus x dy plus dz is equal to 0. You have to integrate this. Before going to integrate, how will you write x dy plus y dx? D of xy, you already know that, isn't it? X dy plus y dx can be written as d of xy plus dz, and you have to integrate this. Okay, integration differentiation get cancelled both the ways. So, here you have xy plus z is equal to constant of integration. This is our first independent solution. Okay, and next we had to find out the next solution. So we had to use the other multipliers x, y, z. Okay, so each ratio will be equal to x dx plus y dy plus z dz by, that is our problem is dx by y minus xz plus equal to dy by yz minus x is equal to dz by x squared minus y squared. And here suppose we are using this multiplier x, yx one is already used, isn't it? So next multiplier we have to go for, suppose we multiply this by x and this by y and this by z. Here when you multiplying this by x and here x squared z you get, here also x squared z. Okay, and similarly when you multiplying this by y squared z, here also you have y squared z is there, and here you have a and remaining terms y squared z is there, y squared z is there, and here x squared z, x squared z, all the terms get cancelled. So you have to use the multipliers x, y, z. So each ratio will be equal to x dx plus y dy plus z dz. Okay, so we had to divided by, add it, x into y minus xz plus y into yz minus x plus z into x squared minus y squared. Okay, now we have to take this x, y, z to inside, x dx plus y dy plus z dz divided by xy, here x is taken inside, minus x squared is it, plus here y into y you have y squared is it, minus x into y you have xy, plus z into x squared is it x squared, minus z into y squared you have z y squared. So here xy minus xy get cancelled, minus x squared z plus x squared z get cancelled, plus y squared z minus y squared z get cancelled. So you get the denominator to be 0. X dx plus y dy plus z dz by 0, and each ratio will be equated to 0. That's why 0 is taken here and it becomes 0. X dx plus y dy plus z dz is equal to 0. You have to integrate this. So x dx plus y dy plus z dz. What is integration of x dx? X squared by 2 plus y squared by 2 plus z dz is z squared by 2 is equal to some constant c1. Why we are taking c1? Because denominator you have a 2. That is to maintain the final solution AB. That's why we are taking like that. Okay, nothing wrong when you taking different way. Nothing wrong in that. Okay, so we are taking this 2 to other side. So x squared plus y squared plus z squared is equal to 2 c1. That is taken as B. Already we taking that constant A constant. That's why with this 2 c1 is taken to be some other constant B. So we have, this is our another independent solution. So general solution is phi of u comma v is equal to 0, and u is xy plus z and v is x squared plus y squared plus z squared. So phi of this term is equal to 0. This is our required solution. So only thing in doing problems is you should be very careful when you're choosing the multipliers. Once you choose, when you're choosing multipliers, your denominator becomes 0. According to that, you have to choose the multipliers. Don't memorize the multipliers. By trial and error method, you can easily find out, but practice is very, very important. And we will see the next problems in the next videos. Thank you.